laws of motion, but anyways, I'll just ask it. Suppose this is a m mass, and again same shape m mass. Okay, suppose it is same shape. Okay, I could not draw exactly same. On one of it, there is F force here, and on the other one, right in the center, there is a F force. Is that clear? Is that clear? So, what is the acceleration created? So, acceleration created is F is equal to net external forces F is equal to mass into acceleration in the direction of the force. Here also, what is the acceleration? Net force is F, mass into A in the direction of the acceleration, right? This
Yes.
acceleration is of which point? Luckily, it was right at the center, so the body will go with A acceleration forward. Each and every part will be going with A acceleration forward. It will go really flat like this. Okay. But here, what we'll see is that some points will have a certain acceleration, the other point will not have so much. It will be rotating and going that we can feel, right? Right. So this calculation of A ends up being of which part? Can anybody tell? Anybody? 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 Anybody?
Econ.
Yeah, it is for the center of mass. Is that clear? So wherever you apply the force, the acceleration it creates, which is given by this equation, F is equal to ma, talks about only the center of mass and nothing else. Is that part clear, guys? That
Yes, sir.
is concept number one you should be knowing. Okay, because in this, I'll not make a big secret or mystery out of it. You'll have rolling bodies. You'll have some friction acting here, down, some other forces acting somewhere else. You'll have so many forces, right? So the net, like in this case, the net force F minus F is equal to ma. This A is being talked about, this part. Okay. If it is rolling, your top part must be moving with the higher acceleration, the lower part not that higher, as low as zero acceleration, it may be the bottom part. But this equation is always going to talk about center of mass. Is that clear, guys? That is concept number one. Is that clear? If the force is having an offset from the point of rotation, or if the force is having an offset from the center of mass of a free body, then that force is going to create a certain torque. Is that clear? Is that clear?
Yes, sir.
If the force was acting through the center of mass, the whole body will go as if, I'll just show you. Since I'm on a computer, I think we can easily show this. It will just go without rotating, just like that. Is that clear? If it is acting only on the center of mass. Are you getting the point?
Yes, sir.
So torque is zero. In this diagram case, torque is zero. But if the force was acting somewhere else, not here, if it was acting somewhere else, then how much is the torque? You will draw a line of the force, and from the center of mass, you will drop a perpendicular on it. This we call it as R perpendicular. Okay, this people are somehow they get confused and make it wrongly. And the torque now would be equal to,
R plus F.
yeah, it is R cross F, which gives you F into R perpendicular. Is that clear? Is that clear? And then you can see the sense will be like this. So torque direction will be this. So you can use your right hand rule and say that, okay, this is inside the vector direction is inside. Okay. So when I say vectors, then I have to properly write it as R cross F. Okay. Okay. So that's your torque. Is that clear? Is that clear? So if there are 4, 5 forces acting, there's another force F dash. So you'll draw perpendicular from there to the line of force. That will be r perpendicular dash, it will also create a torque. Okay. Hmm? So that torque will be how much? F dash into r perpendicular. Is it supporting F into r perpendicular? Are they in the same sense? You see, the forces are ulta, but both of them are going to rotate the body this way, right? So you are going to
Yes.
add it up. Is that clear? We'll have to be little vigilant in seeing that which way is the direction of rotation. Okay. Is that clear? Hmm? Is that clear, guys? So these are the basic what you should be knowing before we start pure rolling. Okay. So rolling motion. So rolling motion is this. Okay. So I'm going to give you three situations. Okay. And before that, the real basic, which I know everybody should be or must be knowing it, but still I'll just repeat it for the sake of it. If this is a point on a body, say X, and there is a point on the ground, say A, if there's pure rolling happening, that means there's no slipping or skidding, and this body takes one round, this X will again come back right down. How far it will be from A? How far it will be from A after one round?
Two by
Any doubt? So X will
no.
be back over here. This part, if there is no slipping or sliding, this part is coming here, this part is coming here, this part is coming here, this part is coming here. Okay. So this circumference is going to, like as if there was a paint on the circumference, it is just going to paint this, right? Circumference length is 2 pi r, right? So the center of mass would have gone forward by 2 pi r, right? If one round is taken, right? If it happened in t time, then the velocity will be 2 pi r by t. Okay. Angular velocity is what? Angular velocity is how much angle is covered, which is 2 pi, one round in t time, right? So we can easily see that your velocity is how much? Velocity is angular velocity into r, right? For pure rolling. That I hope is clear for everybody. The distance gone forward is how much? X is equal to r theta. We say when you differentiate both sides, dx by dt is equal to r d theta by dt gives you v is equal to r omega. You again differentiate both sides, and what do you get? Acceleration is equal to r alpha. Is that clear? Is that clear? So
Yes.
this is again basics of pure rolling, no slipping or sliding. Okay. So based on this premise, I'm giving you three situations. One is there was a certain omega, and I threw the ball forward also with a certain v, and it is so that the velocity was exactly equal to omega r. Next situation is very high omega, very high omega, very small velocity, such that v was less than omega r. Third situation is very low omega, very high velocity, such that V was greater than R omega. Is that clear? Is that clear? Now, I am going to give you a statement and you will work only with that statement. Job of friction is to achieve pure rolling. And if there is pure rolling, there is no need of friction. Is that clear? There is no job of the friction over there. Job of friction is to achieve pure rolling. Is that clear? Is that clear?
Yes.
Yes, sir.
Okay. Uh, uh, this should be in your mind before you answer my questions. Okay. Somebody tell me your name and tell me what is the direction of the friction in the first case, forward or backwards. Job of friction is to achieve pure rolling. Okay. I cannot emphasize on that statement more. Okay. Because you people sometimes have very weird notion of how to figure out friction. Okay. Like this is a man and he is walking. Okay. He's walking forward. Which way is the friction acting on the man? He was just standing and started walking forward. Which way is the friction acting on the man?
Backward.
Forward. Okay. Get the point? So the point is friction is not like opposed to the direction of motion and all. Okay. Just throw away all those concepts. Okay. Here you are trying to rub the ground back with your foot, and the ground gives you a reaction forward, which is going to make you walk forward. Okay. Now, thinking so much in rotation is also like a pain, that which way the thing was digging and how it is going to go. It is a pain to think in all those directions. Okay. So, how do I figure out which way is the friction acting on the man? I know I fully believe the laws of motion. I say the man was having no velocity earlier, is being told to me, and the man started walking forward. Okay. So the law says that force is in the direction of external force is in the direction of acceleration. If the guy started accelerating forward or gaining velocity forward or walking forward from zero to some velocity forward, then there must be some force in the forward direction, right? Some external force, it must be there. So I start hunting for the force. Where is the force? If my hand pushes myself, that is not an external force. The only external contact is with the ground, and then earth is pulling me. So my weight is downwards, doesn't qualify for a forward force. I'm just hunting for it. It's the normal reaction from the ground which is making me not go inside the ground. Okay. So that is again not qualifying for the forward force. So the only thing remains is what? Friction. So the friction must be forward, then only I'm going forward. Okay. As simple as that. Is that clear? So it may look weird to the ones who are not very, very cool with your this thing. What do you say? Laws of motion, but you'll have to work very objectively on the question. This is a car. Oh my God, such a rubbish car. 1 second. This is a car. Okay. It's a two-wheel drive car. Wheels are going like this. Where is the friction acting? If it is going forward, friction is acting forward in the driver wheel. Okay. Generally, the front wheels are the one connected to the engine. Friction is acting forward. If there was no friction, that means suppose it was on sand or something, it will just keep on going round and round and it will not give any force. Suppose it was on icy ground. But as soon as it is on something which has friction, it will give a friction forward. Okay. The back wheels, if they are not the driver wheels, most probably, depending on whether it was accelerating that time or not, it is going to have a drag, friction backwards over there. Okay. Now the key is, okay, how to figure out when is it forward or when it is backwards. Okay, so that is what we are going to learn today, or what we are trying to learn today. Is that clear what we are doing? Is that clear? So at least from this talk, it should be clear the body is going forward doesn't mean the friction is backwards. Okay, that is gone into your head because earlier you had bodies like boxes. If a box is going forward, then yes, there is a rubbing that way, and the friction is yes backwards. Okay, get the point? Is that clear? But my slippers and shoes, when I'm pushing it back, those are not like boxes which are getting dragged forward. If you are dead and somebody is dragging you forward, then obviously the friction is backward on the shoes. Okay. But you are alive and you are pushing the ground back with your own leg, then the friction is acting forward. The ground is pushing you forward. Okay, enough talk on that. Let us just do the question now. Okay. And my statement is the statement what you are going to uphold. Job of friction is to achieve pure rolling. And what is pure rolling? Pure rolling is to bring V equal to omega R. Is that clear? Okay, case one, who will say which direction is the friction? Fast, fast, fast. I'm
Sir,
not seeing any hands at all. You tell me your name.
this is Varad. There
Yeah,
is no
Bharat.
friction.
Okay, Bharat says no friction. Is he right?
Yes, sir.
Yeah, he's
Yes,
right.
sir.
Why he's right? Because the job was to achieve pure rolling. It is already pure rolling. Okay, so this body is going forward with some velocity and it is rolling, but I don't have any friction. Okay, so technically the body is never going to stop because there was no friction. That is what happens to rolling bodies. Okay, in actual practical life, the contact point is not a single contact point, and hence there is a certain friction because there has to be a certain counter to the normal reaction torque and all. So, which is not in course at all. We just do a rigid body having a single contact point if it is round. So friction is absolutely zero. Okay. So if it is a truly rigid body like steel on steel on hard steel rolling, so technically it will just keep on rolling for infinite amount of distance and time. Okay. Okay. Next one. Who is going to tell me which way is the
Sir,
friction?
sir.
Body is going forward and omega is too high. You have to give me an answer with a reason. Yeah. Who will say? Who will speak?
This is Apurv.
Who?
This is Apurv.
Apurv. Okay. Tell me Apurv.
Sir, friction acts backward to reduce the omega R component.
Okay, is he right? How many support him? Is he right?
Sir, I
He's
think
not
it's
only
forward.
wrong.
Sir, I think
Yeah,
it's forward.
It's
he's not
forward.
only wrong, and
Forward.
he is badly wrong. Okay. Hmm? Badly means there were only two options. Friction will be forward. Okay. Now let us see what had to be done. I wanted velocity to be increased for sure or not, guys. Hmm? Right? Velocity was less. I wanted somebody to just help and increase the velocity. Okay. Is friction doing that? Yes, it is doing that. I told you the prerequisite. What is the prerequisite? If there's a body, any shape body, and force is acting anywhere on it, it is going to create an acceleration on the center of mass, right? Given by F is equal to ma. I hope that prerequisite was very, very clear to all of you, right? So if the friction is forward, I'm just guessing, okay? I'm just guessing and seeing whether it is going to be helpful or not. Is it going to increase the velocity or not? Is it going to give a
Yes.
forward acceleration or not?
Yes, sir.
And increase the velocity, so that is helpful. Okay, but then I'm worried that okay, it increases the velocity, but omega is quite high. Does it increase the omega? So let me see that this creates a torque or not. Only a torque. Oh, I did not give you the other prerequisite. Torque is equal to I alpha. Torque creates angular acceleration, right? Torque in the direction of torque is your angular acceleration. Okay, so I was telling you about torque and then I forgot to just write that extra line. Okay. So is there a torque? Let us see that okay, this is a body and there are many external forces. One is mg, one is normal reaction, and one is friction. Is the normal reaction giving a torque? No, because there is no offset from the center of mass. Is the mg giving a torque? No, because there is no offset from the center of mass. So no torque from here. Is the friction giving a torque? Yes.
Yes.
And why is it giving a torque? Because there is an offset. How much of offset from the center of mass?
R.
From
R.
the line of friction, R. So R perpendicular luckily is the radius itself over here. So it is giving a torque. Okay, so I'll have to write a torque. Okay. And which is the direction of the torque? Which is the direction of the torque? Clockwise or anti-clockwise?
Anti-clockwise.
It is going to rotate this way, right? It is going to give a torque that way, right? That means it is going to generate a alpha that way, right? Angular acceleration that way, right? Right? So it was already having a certain velocity, omega. So is it going to kill the velocity or support the velocity?
Support.
No. This angular velocity.
Oh, sorry.
It is going to destroy the angular velocity, right? Because the torque is this way, right? Alpha is this way, right? Something which was spinning hard this way or spinning hard this way got a backwards torque that is going to reduce that omega. Is that clear? Is that clear?
Yes, sir.
Yes.
So what I'm seeing is that I am here for a double boom with friction. What is the double boom? One, it is increasing the velocity, the linear velocity. Secondly, it is decreasing the omega which I wanted, right? So it is quickly going to achieve the pure rolling. Why? Because ultimately I wanted the velocity reduced to a certain, sorry, increased to a certain amount and omega reduced to a certain amount such that this happens. Is that clear, guys? Is that clear?
Yes, sir.
Okay, next one. Tell me whether we have a favorable friction in this next case or not. Do we have a certain friction which is going to help out in reaching pure rolling? The first thing is, will we have friction? We just have to check this line. Is it pure rolling? No, it is not. So job of friction is there, all set. Okay, that I have to achieve pure rolling. So there has to be friction. So only two considerations, forward or back. So somebody tell me what's the answer.
Sir, Manish.
Yeah, Anish.
Sir, friction will be backwards.
Okay, he says backwards. People, anybody disagrees? Anybody?
No, sir.
Yeah. So he's absolutely right. Friction backwards is going to help me
Increase.
bring velocity down, okay, which was high. And thankfully, it is also going to bring the omega up, right? Can you see that? If friction is backwards, your acceleration will be backwards. That means your velocity is going to get reduced. Good for me. Okay. Then which way it is going to create a torque? This is your body, this is your F. It is going to create a torque this way, right? Is it supporting the omega? Yes, it is supporting. So torque is going to give alpha. Alpha means change in omega. So change in omega is going to be in support of the direction of the omega itself. It is going to increase the omega. So double boon over here again. Is that clear? Is that clear, guys?
Yes, sir.
Is that clear? Okay, then do the question. So I'll do two levels of question. One a very basic question, and after that a little more involved question. Is that clear? On pure rolling, then rolling part ends. Okay. Okay. Any doubt? You ask me. Any doubt till now? Ask me.
So,
Yeah.
sir, could you show a case where like friction is either supporting the velocity and not, and also not like not supporting the omega, like opposite of what you're telling, you telling the double boom, right?
Yeah. Okay, I'll show you. 1 second. Boli sir. Okay, so it is always going to be of a double boon. Okay, so like this, say I'm going to give you a case like this. 1 second. Undo. New page I'll draw. Where's the undo? Yeah. Say I have spinned it backwards with my hand and given it a forward velocity. Okay, and thrown it forward on the ground. Okay, something which you have rolled down in your hand and thrown it forward. Is that clear?
Yes.
Okay, what is going to happen? If you have rolled it like immensely, you have spun it backwards and thrown it little forward, most probably towards the end, the body is going
But
backwards. Okay, whereas the spin was not that great and the velocity was forward, it was going forward. Okay, in
yes.
the point. Anyways, big deal. When it lands on the ground, what do you think is the friction? So it will always be a double boom. Okay, so what do you think it will be?
So does it depend on, like, the values?
It depends on omega.
No.
So when it
When
hits,
it is just when it is there, it is going to
Oh
achieve,
no.
try to achieve something, and ultimately it will be either going forward or back, which I'll explain. Like in fact, the last question will be this only. Okay, it is going to hit a wall and this and that, something like this. Okay, I'm going to do this as the last question. I'm going to do only 2 questions. So shall I wait for
So,
that time? See, 2 options. How will you work on it? 2 options. Say the friction was forward. Okay, say. Okay, maybe a very bad choice. Say it was forward. What does it do? It increases the velocity even more, right?
yeah,
Right? And it increases the omega backwards also even more, right? Why it increases? Because alpha will be that way. So this is a absolutely wrong choice, right?
yeah,
Okay.
yeah,
Suppose the friction was backwards. Ultimately, you had a feeling, no? Either it will slow down or it will be totally back, right?
yeah,
So who is that external thing which is either going to slow down or totally back? It is F backwards. Okay. F may be so much that it is totally back, or it may be little less and it is just slowing down and still forward, but it is backwards. Now, is it of help? Let us see whether it is of help or not. It reduces the velocity, yes, and it tries to make the omega forward or not. Ultimately, in my head, I'm imagining that everything is forward. It tries to make the omega forward or not,
yes,
right? And it is trying to achieve a pure rolling situation. Is that clear?
yeah.
Is that clear? Okay. So friction is always double boon. Okay.
So in this
So
case,
now let us just do it. Actually, I have a limited time. Let me just do the first simple question and then you ask me all your doubts. Okay. So that the people who have to go may go away and do their self study after this. Okay. Okay. Both of it will be covered. Therefore, I'm not encouraging you guys too much right now because both whatever I've taught will be covered now in the question. Okay. So this is a solid sphere. Anybody knows the I of a solid sphere? Moment of inertia of a solid sphere?
2 square.
Yes, guys?
So 2 by 5 mr square.
Okay. Got the point, people? Suppose it is 2 by 5 mr square. Okay. I is given to you. I'm saying that this is on ground, just lying over there. And then I come and I put a force on it. The force is put at a height above the R. And how much is that? That is R by 2. Is that clear? So there is the offset. Okay. In the point, force is F. Is that clear, guys? Is that clear?
Yes, sir.
Solid sphere. Now the ground is free to give friction. There is enough to give friction. Okay. And you have to figure out how much is the friction and which direction. By the way, just as a off remark, in pure rolling, if it is free to give friction, it will be pure rolling. Pure rolling is a case of static friction. That means there is no actual rubbing. It is just rolling on one of the other thing, and it is not rubbing. There is no one part rubbing with the other part. It is just rolling. I hope you can imagine that. Is that clear? Is that clear? Static friction doesn't follow any formula of mu n and all. You cannot apply this formula. When does the formula come of F is equal to mu n?
Kinetic.
When there is a rubbing. Okay. Is that clear? So in situation, according to situation, you will calculate how much is the friction. Like if there was 10 Newton force on a block and the block is not moving and somebody asks you how much is the friction, you will obviously say the friction is how much? I'm seeing that block is not moving, then friction must be equal to 10 backwards, right? Right?
Yes, sir.
Where on the same block, if you apply 15 Newton and you see there is no movement, you'll say friction is 15 backwards. You apply, say, 10 Newton from this way and you say there is no movement, then you'll say friction is 10 Newton forward, right? So it is all on the situation, right? Because it is static. As soon as it starts moving, you will go to the formula and say the friction is the max limit, which is mu n. Is that clear? Is that clear? So do not apply the formula of mu n in pure rolling. Note it down in capital letters in your mind. Okay. Friction is not mu n in pure rolling or static friction. There is where the competitive exams try to make you analyze, and the question seems to be more tricky or trickier than the normal questions. Okay, so my question is, which direction is the friction? Tell me fast. With a reason. Yeah, somebody. Yeah, anybody?
So is it forward?
Okay, reason? See,
So
there are
this,
only two answers, back or forward. Okay.
yes, sir.
Yeah.
Force induces a torque which increases omega in clockwise direction. So we need the friction would try to reduce the omega.
Why it will reduce the omega?
So torque is applied.
So why it has to reduce the omega?
So to achieve pure rolling.
Why? No. So your answer is forward irrespective of where I am putting the force, right? Meaning to say, your logic will be same if I had put the force over here. Yo, what's happening, man? 1 second, guys. If I put the force over here and I say the height of the force is say r by 4, does any of your reasoning change? It is going to give a torque and you want a friction to counter the torque. I don't know why you want a friction to counter the torque. That is what I'm not getting.
Sir,
So
Okay. Anybody else? Yeah, yeah.
sir, ACOM is going to be F by M. Alpha is 5F by 4MR.
1 second, guys. यशी जी उनको बोल दो, इसको दे सकते, नीचे गए ना अभी। हाँ ठीक है, मैं बोल दूंगा। Yeah, sorry guys. Tell me. Tell me.
Sir, ACOM is F by M. Alpha is 5F by 4M.
Hmm.
So alpha R is going to be greater than A,
Correct.
which means that means it should be forward friction to counter the excessive omega.
Correct. Okay, tell me how much must be the acceleration ultimately? How much is the acceleration ultimately?
ACOM
Yeah.
F by M.
After all, everything. Friction is acting and everything. What is it?
Oh, 1 second, sir.
Yeah, that's okay. If you say 1 second, then I'm happy. Otherwise, if you say F by M, then I'm not happy, because with your first statement, I'm not very clear that you're fully right or not, but you are pretty much right. Okay. Your logic is correct. Okay. So after the correct logic, if you work out a wrong answer, it will be quite a tragedy. Okay. So guys, for static friction, the best ploy, the best plan of figuring out static friction is what? Assume no friction. Okay. Assume there is no friction. So whatever your calculation will be a wrong calculation, by the way. So you can't go by that calculation, but it is at least going to give you that if there is no friction, this would have happened. So job of friction is to pure roll. So what should happen? Are you getting the point? Are you getting the plan? Okay. Are you getting what I'm saying, guys? Okay. So if there is no friction, okay, let us just do it. There is no friction, then we have two equations, one for F is equal to ma and one for torque is equal to I alpha. So F is equal to ma is what is the net force? There is a force, there's a force down mg, there is a force up, normal reaction, which is going to do nothing to the forward. Forward force is F is equal to ma. That's your forward acceleration. Is that clear, guys? Is that clear? End of story. Okay. There is no friction, suppose. So what is going to happen? The body is going forward. Is it rolling also? Yes, there is a torque. How much is the torque? How much is the torque? Torque is equal to I alpha. Torque is given by the force, and how much is the offset from the point of rotation? F into R by 2. Is that clear? Is equal to I alpha. How much is I? 2 by 5 M R square. Is that clear? Is that clear? Times alpha. Is that clear? Is that clear?
Yes, sir.
So this 1 hour gets cancelled, and let us just check with the MR alpha, because we have got a MA and we have to compare. What have we got to compare? We have to compare my A with R alpha, right? Who is winning, right? That's the main thing, right? That is going to decide the direction of friction, right, guys? So we have our MR alpha is equal to 5F by 4, right? It means what? R alpha is greater than A or not. That's our conclusion, right? And if there was no friction, R alpha would have been greater than A. Is that the conclusion? Is it clear, guys? Is it clear?
Yes, sir.
Yes,
If you
sir.
want me to repeat, I'll repeat. This F is going to give a certain torque, which is going to create a certain alpha. And we are comparing this alpha with this A. Is it like a very sweet spot, and alpha is equal to alpha R is equal to A or not? So what we find is that alpha created is a bit too much. A is not that much. Why? Because it is like F is at a decent height, and it is creating too much of alpha. The offset from the center of mass was too much, so alpha is too much. Okay. So if alpha is too much and A is not that great, then I have to have a friction directions which supports A. So F must be forward so that A rises, and alpha, obviously this F is going to give a backward torque, right? It is going to give a backward torque, and your alpha will decrease, which is going to bring a pure rolling. Is that clear? Is that clear? Then what is alpha and A? All this calculation will go for a toss, because this was not the actual calculation. This is wrong. This is just to figure out which is F. So got the point, right, guys? That which is the direction of F? In this very simple question, by chance, if you had taken F backwards and did some calculation, ultimately you'll get a negative F and you will figure out that it was forward. But that is because this question is simple. Is that clear? Is that clear? So once you have figured out which direction is F, I'll again repeat. I calculated alpha as if there was no friction. I calculated A as if there was no friction. And then I compared. And I got to know that, okay, alpha R is greater than A. And then I'm saying that I should have a friction which reduces the alpha and increases the A. Then I'll do my recalculation on what is the net force on the body. It is F. Can anybody tell me this equation? What should I write for translation? F plus
F.
F, right? Because both are in the same direction. Equation number 1 done. Okay. Equation number 2 is of the torque. So torque is equal to I alpha 2 by 5 mr square alpha. And what is this side? The torque. So what are the torques? There are two forces. Each force will give a torque. This will give a torque. That will give a torque. Let us write due to F. How much is the torque? So how much is the torque due to F?
F
It is
into R
F into R by 2. What is the torque due to the friction?
smaller F into R.
Small f into full R, right? Because it is R away, right? Are they supporting each other? Are the torque in support of each other? Are the torque in support? Can you see the blue force, blue torque? It is clockwise, and the green force, green torque, it is anti-clockwise, right? So it is so much minus, right? Is that clear?
Yes, sir.
Okay, and we say that we have put in friction such that my alpha becomes, A becomes equal to R alpha, then I can just replace my A with R alpha and write it as M R alpha. Is that clear? Is that clear? So that's the end of story pretty much. If you want me to solve it, I can just solve it. R and R gets cancelled. You see a very cool format of MR alpha, MR alpha. If you add the two equations, plus F and minus F will get cancelled. Okay. And before I tell you the answer, I'm pretty sure that my friction is going to be very small value. Why very small value? Because my force was giving a torque, which was giving a good alpha, and it was giving a forward acceleration. So my force was able to do a pretty decent job for pure rolling. It was just that it was little off. Okay. My R alpha was little off. So friction has come in, which is like it acts doubly here and there. So very little friction is going to actually help me into achieving pure rolling. Okay. That is like a sense of physics. Okay. So now if I add the two, what do I get? I get 3F by 2 is equal to, we have a 5 plus 2, 7 by 5 mr alpha. Is that right, people? Is that right?
Yes, sir.
So if I cross multiply, I get my mr alpha. What is my mr alpha or r alpha? So that is like a 15 F by 14. Okay. Is my mr alpha. Okay. So my alpha is equal to, or r alpha is acceleration is equal to 15 F by 14 m. Okay. So I asked somebody, he just casually said it is F by m. It is not F by m. My A is equal to Then he said 1 second. So I'm pretty sure that you would have calculated correct. 15 by 14 m. Okay, not F by m. Because a very small friction is acting. It is slightly away from F by m. 1 by 14 away. How much is the friction, by the way? If I use my first equation and write it over here, mr alpha is 15 by 14. So my F is equal to 15 by 14 F minus F from the first equation. This F goes on the other side. Okay. And what is that? F by 14, right? Very tiny F. Right? Is that clear? Is that clear? Understood? If understood,
Yes.
then a counter question on that. Okay. What should have been the height of the F when I required no friction? At this height, I'm requiring a little friction. Okay. Solid sphere is 2 by 5 and hollow sphere is what? 2 by 3.
2 by, yeah.
Okay. What should have been the height of the F so that I require no friction? Anybody? Anybody? So look over here in this. F is equal to ma. R alpha should have been mr alpha should also have been F. Ma is F. Mr alpha is also F. Then R alpha is equal to A. So what should have been the height? 2 by 5 or not?
Yeah.
Yeah.
Yeah, slightly lower, right? Had it been slightly lower at a sweet height of 2 by 5R, then my F would have produced exactly the same torque what how much acceleration it is producing. Okay. The alpha and A would have been exactly same and it would have been pure rolling. Any point above is too much of alpha. So any point below will be too little of alpha, right? So if I push anywhere over here, what happens? My friction will be backwards because alpha is too little, right? Which we know when we have to push a body, if we push from the down or below that sweet height, if we push, then there is a drag. We have to push a lot. If you push from the top, if you have ever tried, okay, you set in the rolling, okay, in the point and it starts rolling, okay. So this would have been the sweet height where your force is optimal, okay. And if you want the friction to support you, then you push even from the top. Friction is going to support you. That's good for you, right, guys? In the point. So if I just want to take it, extend it a little bit as a theory, if the I was kmr square, like half mr square for a cylinder, kmr square, then this calculation would have been kmr alpha over here. I hope you can see. Okay. The force should have been at a height of what? Kr, like 2 by 5R for a solid sphere, 2 by 3R for a hollow sphere, half R for a cylinder. Okay. So that my Kr gets cancelled. And what I get? I get F is equal to mr alpha. And you have a no requirement of friction. Okay. Because R alpha is exactly A. Understood this point? Understood this point? Understood? Okay, just to make sure that you have understood, just tell me for which shape I should be putting the force right on the top to achieve pure rolling without need of friction. The ground has no friction and I have to do pure rolling. Where should I put the force? Is Kr height I should put the force? One question done. Other question is, which shape requires the force to be right on the top? Your answer can be none of the shapes. What do you think? Which shape requires a force right on the top? Bolo bolo.
Sir, ring.
Absolutely right. Ring. Ring has a moment of inertia of mr square, right?
Yes.
So k is equal to 1. So you have to be kr away. So 1r away. Okay, right on the top. Is that clear? So
Yes.
I'll give you a question. I'll do angular momentum next concept class. So Monday I said, right? And the question which I had to give, I'll do in that because I have promised that it should be 1 hour class. So I will keep it as 1 hour class. And you can demand me whichever topic is there and I'll do that topic for you. Okay. Any topic of physics, any topic of physical chemistry, and few topics of maths. Okay. So you can tell those which I cannot do or I don't have time. I will ask somebody else to do that. Is that clear? So question is, guys, you guys have HC Verma, right? Last year
Yes.
everybody had HC Verma.
Yes.
There's a wall like this. It is unsolved question, third last, fourth last, fifth last question. Okay. In our times, it used to be over here in the page. Okay. I don't know where it is now. So there is a ball thrown with a certain omega. Okay. And there's an impact and it will come back and you have to find out. Okay. What is the, this is a question which I'm going to do next class, but if you want to give it a try, you can do it. This was the question for today. And just before this question will be a similar question that you have spun something and thrown on the ground. Obviously, omega and v are not matching. V is not equal to omega r. Either omega is more or v is more. And then what is the ultimate pure rolling velocity? Is that clear? That will be one before this question. Two questions are there, one after the other of the same concept. Okay. Here, if I teach you angular momentum, then it is better done with angular momentum conservation. It comes in one line. But right now, since angular momentum is not done, you can do it. I'll give you the hint. You can do it by first figuring out which direction is the friction. Then you do a V dash is equal to V plus AT. A means F by M. Okay. Okay. And then
Yes.
you do your omega dash is equal to omega. Most probably, if I'm drawing like this, then minus alpha T. Alpha is how much? Alpha is torque by I. Okay.
Right.
So when you do this and you equate your omega dash and v dash, like omega v dash is equal to r omega dash, you get your answer. Your t's and all, whatever variables you have taken, t's and f's will get cancelled. It will just vanish. Okay. You can take ft as a single variable. Ft is going to figure here also. Fortunately, ft is going to figure here also. Ft as a single variable you can take and you can vanish. So this is a longer way of doing it. The same thing can be done in a short way by conserving angular momentum. So that's a topic for the next class. Today I wanted to do it with the long way because we have done f direction and alphas and all. Okay. So give it a try. Okay, guys. This is the key. Find out the direction of friction and then use these two equations. Okay. You want to note it down, you can note it down.
Sir, I have a
Yeah, any doubt on things which I've taught today, you may ask. Fast.
sir in the spear rolling case. If there is a force at an angle, will both the component, depending on where the force is, will both the components of the force be providing or opposing the more angular velocity?
I did not understand really. This is a sphere. Yeah, then what?
If the force is at an angle,
It is on a ground. Sphere is on a ground.
yeah,
Okay, I'll just make the ground there. Yeah, somebody is pushing it.
yeah, at some random angle somewhere.
Okay, I will push it like this. Huh? Okay, then.
So will is to find the A component, I'll have to break it into components and only use the horizontal.
Yeah. See,
So, but
you'll write your F is equal to ma and torque is equal to I alpha. So I'll just write it for you. You first torque is equal to I alpha, I'll write it. That is easier. Okay, I'll just make this geometry for myself. Get the R perpendicular. Is that clear? So for torque, don't write two components and the torque with two. It will get the same answer, but it will just take longer. Okay. So this full force into R perpendicular, F into R perpendicular is equal to I alpha will give you your alpha. Is that clear? Is that clear?
Yes.
And we know that, okay, with this force, the body is not going to fly up and all. Suppose all that is very known and you know that it is going to go forward only by the constraints or other things very obvious in the question. Okay, then you will say that, okay, for forward acceleration, I need to know forward force. So you'll break the force into forward direction, right? Somehow this angle would be given, right? So you'll write your forward, okay? Forward is how much? F cos theta is equal to MA. Then you compare your A with your R alpha and decide whether it is going to give a friction backwards or friction forwards. Is that clear?
Yes. Yeah.
Yeah. Okay, if it is clear, just answer me a puzzle question. Same force last time, okay? At a height of how much? Half R, right? R by 2. Same. 2 by 5 is your MR square is your I. If that force was at this angle, at say a 30-degree angle, will the friction be backwards or forwards?
Sir, I couldn't hear your last line. Can you repeat?
Ayyo. Same question, okay?
Yeah.
And instead of force being flat,
Yeah.
if the force was this way, at some angle, okay, 30-degree with the horizontal. Same previous question, okay? Hmm?
Yeah.
Then the friction will come again forward or backwards, or you'll have to calculate and all, and you can't say. What is it?
One second.
Rest may just drop off if you don't have any doubts, guys. You may go away. Don't say I held you back. 10 minutes delayed, so 10 minutes I also delay, and then 1 hour class.
Sir, it'll be forward only.
Forward, right? Right? Even more forward, right?
Yeah.
More than the previous answer, right? Okay, so much of physics sense. That's very good. Okay, why even more forward other people? Because this has a greater force arm now, right? It will create even bigger torque. First of all, the torque was good. Now it is even bigger. And double trouble, the forward acceleration will be even less because it is at an angle. So the forward component will be less and this will be even less, right? So at whatever angle it goes down, 30-degree, 5-degree, 10-degree, it is forward only. Is that clear? If it is like this, then we have to really check the angle to see whether it has gone below the sweet height, which was 2 by 5, or it remains above the sweet height. Is that clear? But if it has gone
Yes.
down, so that much of like some physics sense should always be like, we should always be thinking in those terms. Good. Okay. Anything else, guys?
No.
Anything else? Chalo, bye bye. If no doubt, if you have any doubt, be shameless in asking the doubt. This is the last opportunity for you to clear all your doubts of class 11.
So just in the previous question
Yeah.
that you had given us the puzzle, can you just explain it a little by applying equations of motion and telling me if friction is forward or backwards? I just did not get that point.
The point is we should not be applying the motion. When we already know the answer, we should apply the logic.
So, but I'm just comparing it. I've calculated for like alpha, and then with the
See,
torque.
for this situation, um, 1 second, let me just correct the values. 2 by 5, right? Hmm. Yeah. Hmm. For this situation, my alpha was coming large, right? For this particular situation, is that okay?
So I'm getting confused there as well. Just 1 second.
That's right in the starting, what we
Yes.
did. Okay, shall I clean and write?
No, sir, I've got it because it's 5 by 4 times of f.
Yeah, alpha was coming more, right?
Right.
So what was the conclusion? My alpha R alpha was greater than A, right?
Yes.
A was because of F, right? Right? Now, if I make my F this way, if my F is this way now, I have increased the alpha even more. Why do I say that? Because F value is F only,
Hmm.
and the force arm has become how much now?
Times the
Force
distance.
arm will be this one, no? It will be higher than R by 2 or not? Just by the diagram, can you see?
Yes, sir, it will be higher than R by 2.
It will go away, right? From there, right? You
Yes.
can do some simple geometry and figure out how much. Okay. Is that clear? So
Yes.
alpha I've increased. Okay. I'm still not done. Alpha I've increased. That's a bad thing. I hope I have increased the acceleration also. But then acceleration have decreased. Why? Because acceleration depends on the forward component of F, right? If this is full F, forward component will be less than F, right? F cos theta, right?
Okay.
F cos theta. So I have decreased the F also. I have decreased the A also. That's a very, very bad thing, right? That
Yes.
means the friction has to be now big time forward. Okay. If you calculate this time and you do whole calculation like this, you are going to get friction, not F by 14. You'll get bigger than F by 14. Okay. Because now friction has to be like big time to increase the A decent amount and to counter the alpha decent amount, right?
Right, sir.
Okay. And obviously, you'll have to do all this math to actually calculate. But I'm saying if the logic is not there, your math equations may go wrong. Okay. It's very highly probable that if the logic is going wrong, your equations will also go wrong. Okay.
Okay, sir.
Okay. Anybody else? Any doubt?
No, sir. Thank you, sir.
Chalo, bye bye.
Thank you, sir.